Hey guys, welcome back to part 2 of the crash course in Java for creating a server and multiplayer networking in Gamemaker Studio 2. So in the previous video, we went over basic data types and variables along with some arrays and a little bit of other stuff. So that was kind of the basic introduction. Now we're going to go over classes and creating objects, as well as a couple of the different data structures. Okay, so let's go ahead and get started. So previously we used what we called an array, or it is called an array, and we can use this a lot of times for different primitives and stuff like that, or different objects, and that's just fine. But what if we want some functionality in this array to maybe sort it or set a specific value at a specific position? If we wanted to do this in a regular array, we would have to write functionality for the rest of the array to be pushed up. So if I wanted to insert a 1 at runtime right here, I would have to write something that would move all these other values up a notch, right? And I would have to write something for if I deleted a value to shrink the array. It would basically have to create a new array, store the leftover values in that array, and that would get kind of messy, and that's already done for us in a data structure called a list. And Gamemaker has these, DS list, and Java has these, and it's called an array list. So I'm going to get rid of my for loop here, and I'm going to get rid of my int of documents, and let's go ahead and create new documents. A new array list of documents. So what we're going to use is a list, and it's going to be a list of integers, and we say it's a list of integers by using these arrow brackets, right? So we say, hey, we're going to have a list, and to define what is going to be inside of that list, we put it inside of these brackets, okay? And now we have to give our list a name. We're going to name it documents once more, and we have to create an object because a list is an object. Just like we had to do new int, we have to do new list of ints. Or we don't even have to say of ints again, but used to you had to specify here. And then since it's an object, we also have to have these regular parentheses after it. Anytime you create a new object that's not a primitive type, you have to use these braces, because if I go into a list, I didn't think about this just now, but so this is going to be kind of complicated for beginners. So in a list, you can't actually store a primitive type. The way Java is created, you can't store a primitive type. And remember, an int is a primitive type, a double is a primitive type. So what we have is what we call auto boxing, or it's called a box for an integer, and we actually have an object named integer. Now, if we go into the integer, remember we can hit F3 when we click on it. This is actually a new class that is made in Java. You can see it extends number. We'll talk about inheritance later on. You could think of this as like an object inheriting from another object in Gamemaker. Don't worry about implements. Basically, this is saying you can compare two integers, and it has a way of comparing. And you could say we have a min value, max value. That's fine. These are static. So if you want to actually get the maximum value that an integer can hold, you can actually say integer dot max value, and that will actually give you the maximum value that an integer can have. We aren't going to worry about that. We might use it one day. And you can see all these different functions. Basically, this entire class has a lot of different functions for integers that you can use, like you have a decode that you can take a string, and I don't even actually, it tells you what it does in the comments, but I don't think I've used that before. But you have a compare, so you can compare two values, two integers, and you can see these actually take in the primitive data type. Anyway, what I'm getting at is it holds an int inside, but it's an object. So you actually have to make an object go inside of a list. And you see we get this new error now. And we're going to import a list, and I'm going to use Java util. That's the one that we're going to go with most of the time, all the time probably. And these are just different lists from different packages, basically. We're going to use the Java util one. And what the import does is say, hey, whatever is in this package, this is like inside of our library somewhere, right? Whatever's inside of here, I want to be able to use it inside of this class. So if I go to another class and I use list, I'm going to have to do the import, and Eclipse makes it easy. We just have to hover over it. And now you can see that it says cannot instantiate the type list, okay? So a list is not actually something that we can use directly, okay? it is what we call a parent. Sorry, I'm blank on this. It's a parent of a class that we can actually use. So this parent is actually an interface. What an interface is something that is like a contract, okay? So this list, which takes a type, E just stands for a type, and we passed an integer, so anywhere where E is inside this class is now going to be an integer. But anyway, you could see that there's not actually any code doing anything in here, okay? You just see these one-line pieces, boolean, retain all. We don't actually see any code that does anything. We have clear, we have equals, boolean equals. What these are just method signatures. It's just a signature. So this list doesn't actually do anything. It says if I want to create a type of list, I must have all of these things inside of it. Okay, if you were to make an object and you could actually extend list, so like a child object of list, you'd have to add all of those signatures, and you'd have to add functionality for each of these signatures. And we can go over that more in detail later. But what we can actually use is an array list, okay? So there's reasons why we initialize it as a list. You could actually use array list like this, and that would work just fine. But we're using this inheritance, this hierarchy to our advantage. So we're using a list over here, and then the type of list it's going to be is going to be an array list. And there's different types of lists that we can have. We have linked lists and different types of stuff. But an array list, if we go look at it, it actually has implementation of all of that code. So it actually has like real code in here. It's actually doing things. And all an array list is it's an object that can modify basically an array, okay? So you could actually see that it actually has data that is just an array of some type of object that we passed into these little brackets, and it's just some type of object, and all it is manipulating that array. That's all Gamemaker's list is also, okay? So what kind of functions does it have? First, let's go over how we made this. We made a list. It's type integer, which are ints, and it's called documents, and it's going to be a new array list, and this doesn't have a size yet. It's just empty. It's an empty list. So the first thing that we can do with an array list that we can't do with a normal array is use its functions. So we can actually do if, and inside of an if you're doing an if statement in Java, you have to have parentheses here. We can do if documents dot, and you can see all these things pop up. These are all methods that we can use from this array list that are here for us. Like we have like a size, we can get the size, we could set a specific position, we can sort it using a comparator. We're not going to go over that. We can get the last index of a specific element. We can add all, we can add one list to another list, we can remove a specific object from there, and we'll go over all this in more detail. But we can use like is empty, and if document is empty, then maybe we can use that system.out thing again, system.out.print line, and we'll say there are no documents, okay? And so we made a new list, and then we could say if documents is empty, print out there are no documents. And you can see it printed out there are no documents when I ran it. That's because our list is empty. So let's go ahead and add something to our list. Let's say documents dot, and how do we add to a list? We just use add, and let's add 15, okay? And you might be wondering, wait, I thought we had to add an object into our list. Well, what Java does for us and what the list does for us is it takes this 15, which is an int. It's just an int. Like we could put health in here, right? Health is an int, obviously. It's up here. That's a 1. Okay, and we've just added health into our documents list. And what it did for us is box our health variable, our int. So it actually put that int into an integer object, into one of these things, okay? The int now is inside one of those things. So now what we could do is run it, and we shouldn't get that message anymore because our list or documents is no longer empty, okay? And I'm going to rename this health to document, and let me show you something else that's pretty cool. In Java, we can right click, we can go to refactor, and we can hit rename. You can see Alt-Shift-R will do the same thing. And then I can rename this to, let's say, documents. Okay. and I hit enter, and it renamed all instances. It actually will rename an entire project through different files. It's pretty nice. So we just added one to our list, and now we could do else. So if documents is empty, print that out, or else. I'm gonna actually add these squigglies, brackets here. So if you're using an if statement, you can actually do without brackets if you're only gonna have one line. If you have more than one line, then you need to have the brackets, and it's good practice just to always use the brackets, okay? So if the document isn't empty, then we can write a for loop to print out all of the values of our documents. And this is going to bring us to the for each loop. So Gamemaker doesn't have this yet, but we can use it in Java. So I'll show you what it is. So you know the standard for loop. You could set I, you can go through all the indexes, but we can do for. And this is really good for any type of loop where you're just looping through a list or some type of collection, okay? So we could do for, and then we could say maybe, let's say for each integer inside of documents. Okay, and obviously this isn't going to work. It's going to say syntax error, insert identifier, which is a name. So we have to give a temporary variable name. So we'll say for each document, for each doc inside of documents, and then let me give it the curly braces to make this not complain. So this is a for each loop. It's this simple. Okay, so our documents has a type of integer, we could see here. And we're saying for each integer inside of our documents list, we want to do something. And we have to give a name for, as it iterates through our documents, all of our documents, it's going to assign the current one to doc. So we can actually use that. We could say system.out.print line, we could say doc, okay? And it'll actually bring that down. It'll actually unbox that integer for us, or use the toString. You could do doc_toString, which is actually part of the integer class, which will convert that number to a string. But it's not making us do that right now, or it'd throw an error at us. So it's going to go through each document in our documents list, each integer in our documents list, and print out the value. So we can actually run this, and it just printed 1. So let's add a couple more values. I'm just going to copy and paste this. Just copy and paste it, Control V, enter a few times, and I'm going to change the values of a couple of these. You can enter whatever you want. And now if I hit play, you could see we actually printed out all the values. And we can actually use remove. We could say documents.remove, and we can give it an index to remove, okay? And let's give it index 3 to remove, okay? And that should actually remove 0, 1, 2, 3, 177 from the list. Awesome, it did. So now we only have 4 values. Then we could do documents dot, I wonder if sort will work. I actually don't know if it works by default. Yeah, you have to pass something into it. That's fine. Documents dot size, that's fine. You can actually, did we use get? We didn't use get. Let's go to the bottom after all this. We could say sys out. If you type sys out, sys out, and hit control space, it'll actually complete the rest of it for you. And let's print out documents dot get 1 or 2. So this is actually going to get the document at the second position in our list. So it should get 23 because it starts at 0, 1, 2. Okay, so if we hit play, it should print 23 at the end. Awesome. So that's the list, and we're going to use ArrayList quite a bit, and there's other data structures like queues and stacks that we'll go over later on. Okay, so the next thing that we need to go over is creating our own objects. So I'm going to get rid of a lot of this stuff all the way up to our documents. I'm going to get rid of these variables up here, actually. So we're just going to be stuck with a list. That's just fine. And let's make a new class, and we'll call it player. We're going to actually make a Gamemaker object. Actually, let's just call it GM object, okay? So I'm gonna right click default package, go to new, make a new class, and I'm gonna call this GM object. This is going to be kind of like a Gamemaker object. We're gonna go through making it, okay? So let's think about some, first let's go ahead and hit finish. And you can see the super class, before we hit finish, is actually Java Lang object. So basically everything you're creating inside of Java, any class you make, actually is an object. You can reference it as an object. Just like Gamemaker. If you have a parent and you make all kinds of different children, they all are their parent. If you reference their parent, it'll actually return each of them, okay? It's kind of the same thing here. Everything inherits from objects. So we're gonna hit finish. And now we have a GM object, which is gonna be a public class, and we start with nothing. And now let's make a Gamemaker object, okay? So the first thing we need to do is make a create event, okay? How do we make a create event? Well, it's what we call a constructor in Java. So what we could actually do, it's not going to be called create. It's going to be, I'll show you how to do a constructor, and it's essentially the same thing as a create event in a Gamemaker object. Okay, so what we're going to do is we're going to do public, and I'll explain that in a moment. And we're just going to say GM object, okay? And then anytime you make a method, that's what this is called, is a method. And you have to put the parentheses there, okay? That is signaling, hey, there's not going to be any parameters put into this method. And then we have to do the squigglies, okay? So now that we have this constructor, which by the way, this actually gets created. If we were to try to create this class, it would work just fine without the constructor, okay? But it gets generated for us automatically. But it's good practice just to go ahead and create it yourself. Public GM object. And what this gives us is something to create this class, okay? So now what we could do is we could go back, and instead of an integer, let's create a list of GM objects, okay? And you can see it's going to give us an error. Well, I messed up. Okay, it's not going to give us an error. Sorry. And we're going to say GM objects will be our list name now. So we're going to have a list of GM objects. You can see that isn't throwing us any errors or anything. And how would we create an object outside of a list? Well, let's go ahead and go over that. Remember, we have to give it a type. So we say GM object. And we say, let's say player is our variable name. And we could say equals. And remember, anytime we're creating a object or instantiating a new object or instance in Java, we have to use the keyword new. So we're going to say player equals new GM object, and it's going to give us errors. We have to give it the parentheses. And there you go. So what is this doing? This is actually calling this method, okay? Now, what happens if we were to set this to private? We haven't went over private and public yet. It's actually going to complain at us. It's saying the constructor GM object is not visible, and this is going to be a really important concept. So if we set something to private, it is going to only be accessible from its own class, okay? So we can't actually access this constructor anymore, so we can't actually even create the GM object, right? So let's go ahead and set it back to public. We'll return to that point in a moment. Okay, so now we can create a list of GM objects, which is going to be empty. It's not going to have anything in it. We can actually run it at this point, and that's just fine. It won't give us errors. It just will not do anything, okay? So we went ahead and created objects. And what does a Gamemaker object have? Well, it has built-in, let's see, int health equals 100. But we shouldn't have to specify a default health. Does Gamemaker do that? Well, everything's 0, of course. So let's just go ahead and do int health, int speed. We're not going to do every value, but let's do the basic ones. Int x, int y, and then what else do we have? Let's do layer. We have a layer. We could call that a string layer. In GMS2, you have to specify a layer, right? So now we've specified these values, and how do we actually change these values now? So we created this. Now our GM object is actually going to create this, and it's going to create these values. But we're actually not going to be able to do anything with that. Now, if I want to access it, how do I access it? Player.x. Let's create a new integer. Be like our player's x equals. and it's going to complain at this. Hey, can't be resolved or is not a field. Java's not recognizing this X as anything. Why is that? Well, it's simple. This is called scoping in Java. So the scope of these variables is actually only this method. So once this method is complete, this constructor, which I'm actually going to label up here, constructor. Once this method finishes, which is right when it's created, these variables go away. They're gone forever. Okay, they're cleared from memory. So how do we end up saving these variables for an object? Well, what we do is we actually move them outside of methods. We move them to what we call class level, okay? And this is class level up here. So I copy and pasted them above any constructors. So this is not inside of any method. It is right under our class. You can actually put these down here if you wanted. It would work the same. It doesn't matter. But the standard is just right above or right under the class definition, or not definition, but the class, what can I think of it? Up here at the top, class definition, I'll call it, whatever. And now we can actually access those from in here. You see our error's gone. I mean, X won't have a value. It might have 0 right now, but let's go ahead and print that out and see. Let's do a sys out and let's print out our player's X. So I'm going to delete this. I'm just going to do sys out. Remember, you could do this, control space. It'll actually generate that. And I'm going to put this inside. Let's go ahead and hit run. And it printed out 0, because if you don't initialize a variable, a primitive type, it's actually going to be 0. What happens if we try to print out layer, which is a string, right? And we haven't assigned a value to it. Let's go ahead and see. It returns null. Null is what happens when you have an object. Remember, a primitive type is not an object. Ints are not objects. Integers, remember, are those boxes that hold ints. They are objects. But if you don't assign a value to these, then they are null. So they don't actually have a value. So remember, on a string, we could actually use like different things like value of, like we could do a string. Oh, it's not going to let me access it. But remember, they have all kinds of different functions inside of a string. So we should be able to get the player's layer, which is a string, and get something of it. Let's get the length of that string, right? Let's see what happens if we try to print out the length of our layer string that has not been initialized. I hit play. You see we get an exception, null pointer exception. It's basically essentially doing this. Player.null.length, okay? Because we didn't assign a string to that variable. So we're saying, hey, this layer, open a box in memory to hold a string value, a text value, but don't put anything in that box, okay? So then when we call player.layer, it's going to that box and getting something out of it, but there's nothing to get out of that box. It's an empty box in memory. So it's returning this nothing, and it's saying, call this dot length of this nothing. Well, that nothing doesn't have any functions. It has nothing. It's simply null. Okay. So that's why we need to, for objects, we need to give them a value. And if they don't have a value, we need to handle the errors. Okay. So we could just go ahead and say layered equals something. We could give it an empty string, and now we can run it and get the length of that string, and it's 0, right? Because the length of this, it doesn't have any characters. It's 0, right? Okay, anyway, so now we have these values, class level. We can access them from anywhere, essentially now, anywhere else in any of our project. And this is actually not good, okay? This brings us to the next thing. We use private for class level variables. It's the Java standard, and we put private in front of our variables. And I'll explain that in a moment after we do it. Private. Now, why do we do this? Well, there's a lot of reasons. The biggest, most important reason is for organization. And what I mean by that is, let's say you're creating a very, very large application, okay? And originally they were public by default. You could actually specify public. But if you don't have anything, they're by default public. And that means anyone can access them from anywhere, and they could do anything they want. They could set them, they could change them. Well, what happens when your project becomes very large and you have all public variables and they're accessible from anywhere? And by the way, in Gamemaker, all the values basically are public. You can access any object's variables from any other object. How do you know who's changing it or what's changing it? You really don't. There's no way to look up who's changing that value besides searching for that value throughout your project, okay? There's no easy way to find everything that's changing it. And let's say you're getting bugs, you don't know where that bug is coming from, okay? So that's why we use private, and you can see it's going to give us errors. We can't actually access layer anymore. Well, how are we ever going to gain access to that? That's silly. We can't change it anymore from outside of its own class. Well, this is where getters and setters come in handy, okay? And we can actually auto-generate that. If I hover over this, it says create getter and setter for health, okay? And this is just going to create methods, okay? I'm going to hit OK. I clicked that, hit OK. And you can see it made these two variables. And usually, because if you have a lot of variables and you have getters and setters for all of them, it'll take quite a bit of space. So sometimes I do this just to save some space. Okay, and we're going to talk about what this is doing in a minute. But you can see we actually can go back here and we can do player.get health. And it's a function, so we have to do that. And this will work. It's going to return 0. That's our player's health currently by default for an int. Okay, so I did get health, return health. Okay, so let's talk about this function. This function, first of all, takes no parameters. We'll go over parameterized functions shortly. It's public, so it can be accessed from outside. Remember, these values can't. This method can, okay? This is what this method is going to return, okay? And you can see it returns health, which is basically saying, hey, get ready to take in an integer value. So this is an int, so we can actually we could do like int our player's health equals player.get health, okay? And that's actually going to set this int to what this get health method returns. And you can see we say return health. This is just like a script in Gamemaker. It's returning the value of health, okay? And that's actually going into our player's health here. And that's what the second keyword is. You specify a return value. If I specify string here, then we're saying, hey, this is going to return a string. Well, health is an integer, so how can we return that? We could actually return layer here because layer is a string, so it's actually giving us layer. It's returning that value. But we're going to go back to health and set this back to int. So let's talk about the next method that was generated. This is called setHealth. And we could see the difference here. It says void. This means this method isn't going to return anything. So if I were to do our player's health equals player.setHealth, it's going to give us an error. It's going to say this method setHealth and the type GM object is not applicable for the argument. Okay? And what that means is basically, hey, this isn't expected to return anything. That's silly. Well, first of all, we need to, let me add that in. So I think we're getting the wrong error. Let's read it again. It says type mismatch, cannot convert from void to int, okay? So we're getting two errors. We'll go over the first one in a moment. But obviously it can't convert from a void, which means no return type, to an integer, which this is expecting. Okay, so let's change this back to get health. And you see I had to put a value inside that parentheses, and I'll show you why. If we go back, you can see it's expecting something inside that parentheses. It's expecting an int. And it's using this variable health. And you can see if I highlight it, it actually highlighted this one. And it's setting this .health to equal whatever was inside this parentheses, okay? And this .health, if we highlight it, it's actually referring to the class level variable. So we're actually setting our class level variable with this setter, obviously. So let's make getters and setters for everything, okay? Create getter and setter for X, create getter and setter for Y, and then let's create getter and setter for layer. I'm just hovering over these and clicking these. Awesome, you can go refactor or do this if you want, or I'll just go ahead and do this because that's probably where you guys are going to be at. Okay, there we go. So we have getters and setters for all of this, and yeah, it's kind of messy. Other languages have more elegant ways of handling this, but this is what Java developers do. It's not bad. It's just, it takes up a lot of space. I usually put these at the bottom of my class, everything else in between, okay? So now when we create a player and we want to set its X and Y value, in Gamemaker, you could see we give the parentheses when we do instance create, and then we say X, Y, layer, and we just get to do it all inside those parentheses. I'm about to show you how to do that. But right now, the way we have it, if we want to change our player, we have to do player.setHealth after creating it. We'll set it to 100, player.set X to 50. You can see how this is kind of redundant. We don't want to have to do this right after creating every one of our objects, right? So there's better ways to do this. I'm about to show you how. And if I go ahead and hit play, you can see it print our health out. It's 100. If I change it to 1002, it's going to print out 1002. So our setter is working, okay? Now, let's talk about a overriding method, okay? So if we go back to our constructor and copy and paste it, I'm going to name this Parameterised. First of all, it's going to complain saying, hey, you have duplicate methods. This isn't good. We can actually have it take in some values. So what do we do in Gamemaker? We give it X, Y, layer, and then an object to create. Well, our object to create is already here. We already told it what object to create. So let's go ahead and give it an X, Y. So we give it X, int, Y. That's what we want to pass into the parentheses. And int layer, okay? So this is how we're going to instantiate it. And what do we do with these values that we're going to be passing in? And also, this is, once again, a parameterized constructor, and this is overriding the default. And I'll show you how to use these two. So first, we set this dot x equals x. We set this dot y. Remember, we use this, so it differentiates between this variable and this variable, equals y. And then we do this dot layer equals layer, okay? Ooh. Oh, we have int layer. This is supposed to be a string. It yelled at us. That's just fine. So now we have a parameterized constructor we can use. So let's go back. So you can see we can either create this first object, which is going to work just fine. It's just going to initialize everything to 0, but layer will be null, so we won't be able to use it. Or we can use, let's do gm object. Let's create another instance, player2 equals new gm object, and we can assign it our values. We could give it an x position, a y position, and then a layer. Let's say instances. Okay, we have to give it semicolons. That's important in Java. You have to use semicolons at the end. And now we've created a new player using that overriding constructor. Now we could make a third one if we wanted. Let's say we wanted a constructor that we just wanted to be able to give an x and y. We don't care about the layer, right? Well, we could do that too. We could make a third player. Yeah, third player. Player 3, and get rid of that instances string, because we have a method to suffice that. And you could do this for any method. We could actually create another setter, right? We could do set health. We could create another one and give it another parameter. We could say int multiplier. And we could set this health to equal the health that we send in times our multiplier. Okay? And you can see these two are named the same, but they have different parameters, so they have different functions, and Java allows us to do that. And you could actually use that as well. So you pass in a health value, and then you pass in something you want to multiply that health value to, and that'll do whatever you want, which is really kind of cool. Okay, so we've created these three objects. Let's go ahead and add these three objects to our list, our GM objects list. Let me get rid of the system out, and I'm going to go ahead and do this to clean this up. Okay, we can add these GM objects to our list because we have a list of GM objects. So let's say GM objects dot add. Let's add player. And I'm just going to copy paste this to save time. And we're going to add player 1 or player 2 and 3 to our GM list, okay? And since they are the correct type, they're all GM objects, right? Then we can do this, and now let's do a for each loop. So we're going to do for each GM object type. We're going to name the temporary variable to O. That's just fine. And what list are we looking in? Well, we're looking in GM objects. Okay, so it's going to go through every GM object inside of GM objects. And it's going to assign the variable O to reference it. And we're going to use system.out.print line. We're going to say print let's print O.get layer. We can just do O.get layer. We can get the layer of all of them. And this is going to print out null for 2 of them because we didn't assign it. But for this one, we did assign it. It's going to print out instances. So we're going to hit play. There you go. We have null, instances, null. And we can actually do plus. Let's print out our O.get health as well, just for kicks and giggles. That's actually going to be the same for all the objects. We didn't add a space, but it says null 0, instances 0, null 0. And I think that's going to be the end of this video. In the next video, we're actually going to start coding our server. And I know that seems like a lot. This gives you a little bit to go play with. Please go play with this. You can now know how to make methods that take in parameters. You can name them whatever you want. Play with the return types. You can also use getString and getString. If we do O.getString here, string. Oh wait, sorry, not getString. ToString, and hit play. You get this weird, funny thing. And why can we use ToString? It doesn't exist in here. Where's that coming from? It doesn't exist in our GM object. Remember, GM object inherits from object. It is an object class. And you can see that we can actually change this from GM objects to object. And this will work just fine, actually. If we get rid of this, we can use GM objects.get. Remember, we can use get to get a specific index. Let's get the 0, and we can use ToString, and that'll work just fine. And you could say we put actual GM objects inside of a list of objects. Anyway, I think I'm just confusing everyone more. So don't worry about that. Just know it can be done. And my challenge to you, the reason I brought all that up, my challenge to you is to override the ToString method inside your GM object class. Make your ToString method return. If you go into the object.ToString, you can hit F3 on this ToString method, and it'll take you to the object class right here. Okay, see, public class object. You can see exactly how it's implemented. I want you to move this into your GM object class. You can copy and paste if you want, which is going to override this functionality. And I want you to return something, instead of returning this nasty thing, I want you to return something that has all your information. It has your X, your Y, your health, and all your variables, basically. I want you to return a string. Remember, this is returning a string. That's what this is doing. It's making a string. That string is getting returned right here and printed out. So I want you to change the functionality of that inside your GM object to return information about your object, okay? And that's your task. And if you can figure that out, you're on your way. You'll be fine when we start developing our server. All right, I'll see you guys in the next video when we start making that thing. Thanks for watching.